Hello, what we're going to look at today is frequency modulation and looking at the differences between Carson's bandwidth rule, looking at the number of sidebands, looking at the deviation ratio, carrier frequency, and the modulation frequency, and to be able to do some calculations with those various settings. So to start with, what I've done here is I've set the carrier to 10 kilohertz, and you can see that at the bottom. And on my generator, I've set the FM frequency to 100 hertz and the deviation frequency to 0 hertz. So the carrier signal does not change. It's actually staying at 10 kilohertz all the time. And I wanted to do that so I know that my peak value for that 10 kilohertz signal, and it's at minus 2 dB. And on my generator, my amplitude is 500 millivolts peak to peak. That works out to be about 177 millivolts RMS. And my software is set up here and my hardware to give me a 50 ohm load. That's going to be important when I do that calculation a little bit later on. My range is set for 24 kilohertz, so 0 on the left, 24 kilohertz on the right, and you can see that I'm zoomed in at this particular signal. Just makes it a little bit useful to move the cursors around. So I'll consider this step number 2. I have the frequency deviation set to 100 hertz and the FM frequency set to 100 hertz as well. So the deviation ratio happens to be 1.0. And this is something where you may want to look at the Bessel table to see what kind of spectrum you will get. But for now, one of the things I want you to notice is the spacing between each sideband. So I'll put one here, and that's at 10 kilohertz, and I go to the first sideband, and that's 10.1 kilohertz. That's an important thing to note. And based on Carson's bandwidth rule, we have a FM frequency of 100 hertz and a deviation frequency of 100 hertz. So 100 plus 100 times 2 gives me a total of 400 hertz. So let me put markers at those 2 points. So I've put 2 markers to measure those frequency points. So you can see with the deviation ratio of 1, I have a bandwidth of 400 minus 200 on the lower, plus 200 on the upper. And the sidebands that are in there are the first 2 sidebands. Okay, I have the carrier in the center. The first sideband and the second sideband fall within that Carson's bandwidth rule. So that's what you would use to calculate the power. And with the band and that rule, it says that 98% of the power will fall within the spacing that I've shown there between the 2 markers. And that's with 100 and 100 for frequency FM and frequency deviation. So I'm going to make some changes, but I think I've got all of that. But while I'm here, I'm just going to mark off each of the sideband amplitudes. So there's the first, there's the second at 21.15. This drops way down to 36, and then this one to a much smaller. Okay, and that's with a deviation ratio of 1. So I've completed that one. Okay, I've made some changes here. My frequency deviation is 200 hertz, the FM frequency 100. So my Carson's bandwidth is going to be a total of 200 plus 100. That's 300 times 2 is 600. And you can see I've got the cursor set up for 9.7 kilohertz and 10.3 kilohertz. That's a bandwidth of 600 hertz. And you can see I've now have 1, 2, 3 sidebands on the left, 3 sidebands on the right that I would calculate for my power. And I'd also have to include the center frequency or the carrier frequency, which is at 10 kilohertz. And while I have the markers here, I'm going to mark them off for each one of those sidebands. So the first sideband, minus 7.8, minus 11, minus 19 or 20, minus 31, minus 45. Okay. And so for that, just a reminder here, my deviation frequency is 200 hertz, my FM frequency 100 hertz. That would give me a deviation ratio of 2.0 and a bandwidth of 600 hertz. So that's kind of step number 2. Sorry, step number 3. Now let's go to step number 4. All right, I'll call this step number 4, where I have a deviation frequency of 400 hertz and an FM frequency of 100 hertz. So you can see the spacing between the sidebands are the same, okay, 100 hertz. But what's changed? There are more sidebands and the bandwidth is getting wider. Okay, now we have a bandwidth of 1000. 500 hertz on the left, 500 hertz on the right. And that would be the bandwidth for the Carson's rule. You'd want to calculate the power of each of those sidebands. And I'm going to mark off with this. So we have the one here, one here, one here, another one, these two here, this one, and this one. Now, you'd want to go to the Bessel table to look at the relationships of the carrier frequency versus each of those sidebands. And we may do that a little bit later on. But that's the other thing to note here is the deviation ratio is equal to 4. The higher the deviation ratio, the more sidebands you're going to have. Okay, and if you combine the FM frequency and the deviation frequency, 500, times 2, that's going to be your bandwidth. So for this setting, the bandwidth is equal to 1000. Now let's go to step number 5. All right, this is step number 5. Things have changed. Now the FM frequency is 200 hertz. So now you can see that the separation between each of those sidebands is no longer 100 hertz, it's 200 hertz. Okay, and I'll show you that after I discuss other things. But the frequency FM is 200 hertz. The frequency deviation is 100 hertz. And you'll notice that I have much fewer sidebands. And that's because the deviation ratio now is 0.5 compared to the 1, 2, and 4 that we had earlier on. So the deviation ratio is 0.5. But to calculate the bandwidth, it's still 100 over 200. Or sorry, 100 plus 200, which is 300 times 2. So I still have a bandwidth of a total of 600 hertz, as I've shown there. Now, before I leave, I want to mark off those different points again. So I'm going to show you this sideband, which is within, and then this one is outside of the Carson's bandwidth rule, and this one much lower and outside. But I wanted to show you the separation here. This is 10 kilohertz. And if I come over here, this is 9.8. So we're 200 hertz separated. Now, one more measurement. In this last measurement, I'll call it number 6, we have a deviation value of 100 hertz, an FM frequency of 400 hertz, and a deviation ratio equal to 0.25. Now the bandwidth here is actually equal to 1000, and I think I've got that marked here. 500 for the lower half, 500 for the upper half. The difference between them is 1 kilohertz. What's different here is the separation now between, for example, the carrier frequency and one of the sidebands. They're separated by 400 hertz. Okay, so a greater FM frequency, but similar bandwidth by adding up the FM frequency of 400, the frequency deviation of 100, multiplying it by 2, and that gives me the 1000. Okay, now we're measuring in the time domain, not the frequency domain like we were doing. And the main reason I wanted to go to this measurement here is to look at the measurements down at the bottom, this area right here. And it's the first 3 that are important to look at. So what frequency deviation indicates is how far away from that carrier frequency of 10 kilohertz does the frequency change. It'll go up to a certain maximum value, down to a certain minimum value. And I have my generator set to a frequency deviation of 500 hertz, which means it'll go to a maximum of the 10 kilohertz plus 500, and that's what you're seeing there, 2.5, and it'll go to 10 kilohertz minus 500, and you're seeing about 9.5 kilohertz there. And the center frequency, which is the average here, is the 10 kilohertz. So it's changing all the way down to 9.5 kilohertz, all the way up to 10.5 kilohertz as that FM frequency changes. And we've got it set for 400 hertz. All right. I hope this helps. And the other thing I wanted to show you here while we were here is if I set the deviation back to 0, okay, it's at 0 hertz. And now you see, I think I have to do a reset to reset that count. The minimum's 10 kilohertz, maximum's 10 kilohertz, and the average is 10 kilohertz. Okay, and you'll notice that the peak-to-peak value is 250, and let's measure the RMS value because that's something we're going to want to work with later on. So I have the RMS value, and you can see that it's 177 millivolts, and that's going to be important for our next measurement. All right, hopefully all this helps. Thank you.